Imagine this. You've deployed your new app to Kubernetes. You've got your front end, your back end. Everything looks green, all the checks are passing, but they just won't talk to each other. It's a classic and honestly a super frustrating problem. So today, let's solve it together.
We're going to tackle this just like a detective story. First, we'll lay out the crime scene, the pod communication problem. Then, we'll meet the hero of our story, the Kubernetes service. But the plot thickens when things still go wrong. We'll grab some pro tools to investigate, have that big aha moment, and uncover the real lesson at the heart of this whole mystery.
So let's set the scene. We have a really simple setup, a front-end application that needs to get some data from a back-end application. Both of these are running as separate pods inside the same Kubernetes cluster, which you can just think of as its own private little network.
Okay, here's the fundamental issue. Kubernetes is all about resilience, which means pods can be destroyed and recreated at any moment. But here's the catch. Every single time that happens, the new pod gets a brand new, totally unpredictable IP address. Trying to talk directly to an address that's always changing is, well, it's a nightmare. This brings us to the central question, right? How in the world can our front end keep a stable connection to the back end if the back end's address is basically a moving target? Hard-coding that IP address is obviously not going to work. We need something way smarter.
And that solution, the hero of our story, is the Kubernetes service. It's the platform's built-in, elegant answer to this whole problem of unstable disappearing IP addresses. So how does it actually work its magic?
A service basically acts as a stable middleman. It takes a group of pods, like all of our backend pods, and gives them a single unchanging IP address. And even more importantly, it gives them a consistent DNS name. You know, DNS is kind of like the internet's phone book. It lets us use an easy name instead of a hard-to-remember number. The service becomes this nice, clean abstraction layer that hides all the chaos happening underneath.
Honestly, the best way to think about this is like the contact list on your phone. You don't memorize your friend's phone number, right? Of course not. You just tap their name. And that name stays the same even if they get a new number. A Kubernetes service does the exact same thing for your pods.
So here's the bottom line. Without a service, our front end is trying to call a number that's always changing. It's totally unreliable and brittle. But with a service, the front end just calls a stable name, something like backend service. And Kubernetes handles all the magic of routing that request to a healthy backend pod, no matter what its current IP is.
Okay, so we've done everything right. We set up a service for our back end, and our front end is calling that service name. Problem solved, we can all go home, right? Well, what if the application is still broken? This, my friends, is where our real investigation begins.
You know the feeling. You're looking at your app and nothing is loading. You check the logs. Nothing. No obvious errors. Everything inside the cluster seems to be running just fine. But from the user's point of view, the application is completely dead in the water. This is the mystery we have to solve. Let's examine the crime scene. As you can see here, the user's browser loads the front end. But then, the front-end code tells the user's browser, which is sitting way outside our cluster, to make a direct call to our internal back-end service. The whole problem is in that one little arrow. Do you see it yet?
To get to the bottom of this, we need to put on our detective hats and start following the clues. We're going to use a few standard but incredibly powerful Kubernetes command line tools to investigate what's really going on inside our cluster.
Here's our playbook. First, we'll analyze the logs for any initial clues. Next, we'll try to question the witness by getting a shell inside our front-end pod to test things out. And if that fails, it's time to call in a specialist, a handy little tool called BusyBox.
First up, kubectl logs. We see some generic connection errors. This tells us that there's a problem, but it gives us no clue why or from where. The trail goes cold fast.
All right, step 2, let's try kubectl exec. The plan is to get a shell inside the pod and test the connection ourselves, but we hit a wall. Our container image is nice and minimal, which is good for security, but it means there are no networking tools inside like curl or ping. We've hit another dead end.
This is where we bring in the specialist. The pro move here is to deploy a temporary, brand new pod using an image called BusyBox. Think of it as a tiny Swiss Army knife for Linux. It's a super lightweight image, but it's packed with all the essential debugging tools that our main app is missing.
Now, with our BusyBox pod running inside the cluster, we finally have the right tool in the right place to crack this case. This is where we get our big aha moment. Okay, so from inside our BusyBox pod, we run a simple command to call our backend service, and it works! We get a successful response. This is the breakthrough clue. It proves, without a doubt, the communication inside the Kubernetes cluster is perfectly fine. The service works, the pods work, so the problem isn't internal, it has to be external.
And that leads us directly to our prime suspect. The browser, which is running on the user's machine, is trying to resolve the name backend service. But that name only exists within the Kubernetes private internal network. The browser has absolutely no idea what that is or how to reach it.
And with that, case closed. The browser should only ever talk to the front end. It's the front-end pod's job, living safely inside the cluster, to then make the call to the back-end service. This simple change respects the network boundary and gets the communication flowing correctly. So, we solved the mystery, which is great, but there's a much bigger lesson here. This isn't just about learning a few kubectl commands. It's about developing a debugging mindset. The goal is never to just memorize a list of commands. It's to learn the patterns of investigation. It's about knowing how to ask the right questions and how to methodically slice a problem in half until you find the real root cause. So what's the pattern you can use next time you're stuck? First, isolate the problem. Is it internal or external? Our BusyBox test did exactly that. Second, check the connection at every single step of the way. Third, use the right tool for the job. And finally, and this is the big one, you have to truly understand how your application is actually supposed to communicate. We've demystified how pods talk to each other and, more importantly, how to figure out what's wrong when they don't. So the real question is, now that you have a pattern for ensuring your services can communicate reliably, what amazing, complex applications are you going to build?